1958.
Assalamualaikum Pak Purwanto. Oh ya sudah masuk nih Bapak.
Ya, ya.
Ya siap Bapak. Tidak apa-apa Pak. Tadi saya panggil aja, saya kira masih istirahat.
Ya silahkan dimulai.
Pak Purwanto, moderator di sesi pertama ini ya Pak?
Iya, ya betul.
Iya Bapak. Ya berarti
Ya,
nanti
ya.
langsung masuk ke Bapak nih Pak.
Ya.
Untuk mengenalkan
Oh gitu.
CV dari ya invited
Ya,
speaker
ya.
Pak
Saya pikir dari
Suharyanto.
Ya, oke.
Oke
Ya,
Bapak.
orangnya.
Nanti
Ya.
panitia nanti nge-share untuk
Ya,
videonya
oke,
dari
oke.
Prof. Suharyanto. Siap.
Maaf, makasih.
Enggak apa-apa Bapak.
Ya, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for the organizer to it is an honor for me to be a moderator of this session. For this session, it is firstly begin by our invited speaker, Professor Suharyanto. Okay. Yes. I think our invited speaker has been already in our room. Let me read the curriculum vitae of Professor Dr. Insinyur Suharyanto, MSc. He is now a professor of civil engineering, Faculty of Engineering, Diponegoro University. He graduated from Civil Engineering Gajah Mada University as bachelor degree. And now he is in Department of Civil Engineering Faculty Diponegoro University. Mungkin di-share lagi, belum selesai ininya, the CV. Okay. He graduated the master degree from Manitoba University, Canada, and doctoral degree from Swinburne University of Technology, Australia. And his main interest is in hydrology, hydraulic, environmental issue, water resources, and disaster management. Okay, Professor Suharyanto, we have 20 minutes for presentation. I think we can divide it into 15-minute presentation and 5 minutes for discussion. For participants, if you have any question, you can type in a column chat in your window, in your Zoom window, or later directly after presentation from Professor Suharyanto. Okay, Professor, thank you. You can continue. Time is yours.
Yes, thank you very much, Purwanto, and thank you very much for the committee. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
wabarakatuh. Thank you for being invited as invited speaker. It is an honor to me in this occasion. And in this occasion, I'd like to present about the risk and stability analysis of Klego Dam at Boyolali in Indonesia. It is preliminary research on the stability of the Klego Dam based on the data during the inspeksi besar, the big inspection performed by the Balai Wilayah Sungai Jeratun Seluna. Next, please. And the structure of the presentation will be divided into background, condition of Klego Dam, determination of cross-sectional and material properties of the dam, and analysis and discussion, and then conclusion and recommendation. Next. Next, please. Yep. Now the background, thank you. The background, the Klego Dam actually was built in 1990 and operated since 1993. And it is used to supply irrigation water of about 1,353 hectares. The management at that time was by Balai Besar Wilayah Sungai Bengawan Solo of the dam, in the dam management. But the allocation of water is managed by Dinas Pekerjaan Umum Boyolali, the Boyolali Regency. But in 2010, the management of the dam is relinquished to Balai Besar Wilayah Sungai Pemali Juwana. And the water distribution still under the authorization of Dinas Pekerjaan Umum Boyolali. Why there is a change? Because the location of the dam is at the boundary between the
Pak Purwanto, Prof. Suharyanto, lost
Iya.
sinyalnya.
Iya, gimana? Mungkin
Iya,
kita tunggu atau
ya, ditunggu saja Bapak.
iya.
Ini sudah masuk lagi. Pak Purwanto, beliau sudah saya telepon, Prof. Suharyanto lagi trouble internet, sedang mencari untuk tethering.
Oh, begitu. Iya, iya.
Ya, ya, siap
Baik,
Bapak.
kita,
Sebentar lagi Pak, insya
iya,
Allah.
iya, kita tunggu saja. Nggak apa-apa.
Ya.
Yeah, hello, Mr. Purwanto and all the audience. I'm sorry that the connection is lost.
Okay, no problem, Pak Prof.
Can we continue, ya, Pak
Yeah,
Purwanto?
you can continue your presentation.
Thank you very much. Yeah, yeah. The background is that the available data and information of the Cleco Dam is very limited, so that we have to conduct some boring for the investigation of the material properties of the dam. Next, please. Yeah, this is only overview of the location that the Cleco Dam with the circle, red circle, is at the upstream of the Kedung Ambo Dam. So it is under the management of Balai Besar Wilayah Sungai Pamali Juwana, not the Pangan Solo. Next, please. Maybe next. Yeah, maybe can we go next? It's only the detailed location of the Cleco Dam. And this is the condition for the Cleco Dam that we do the survey on the 2017. It is actually it is a small dam. The height is about 10 meters and the inundation area is about 75 hectares, yeah, not 1 square kilometers. Next, please. Yeah, it shows during that period, 2017, that the problems of the upstream slope, there are some material displaced, the rock layer. It is supposed for increasing the stability of the dam is displaced, and there are some activity of some people facing in the dam, and it gives some worry that it may become worse. So that's why we need to do the analysis for the safety of the Cleco Dam. Next, please. And this is for the dam crash, the height of the dam. At the time, it is allowed for the people to pass through the dam crash. I mean, the people, the society use the dam crash as the access route to the neighboring village. So that's why it has heavy traffic on the dam crest that caused the surface rough, and also it is observed the longitudinal crack, longitudinal settlement. It is the condition that is not supposed to be exist in a dam. Next, please. And this showing the condition on the downstream. Also, some rock misplaced. I mean, maybe some people using the moving the rock around. Yeah, and the condition on the spillway. Also, there are some sedimentation. You know, the function of the spillway is to allow water, the flood water, to escape freely and quickly out of the dam. But if there is some sedimentation, it may hinder so that the flood cannot discharge freely. So the next. Also in the downstream area, that there is also some fishbone drainage. Some fishbone drainage along the downstream slope of the dam is clogged with some mud, some sand, soil, so that when there is a rain, the surface runoff, which is supposedly to be concentrated in the fishbone drainage to the drainage channel downstream, it may flow over the dam body that may increase the potential for the dam body erosion. And also the instrumentation are not functioning quite well. Next. The FINOTS. The FINOTS is the instrument to measure the amount of seepage through the dam. So there are two FINOTS. One FINOTS is not functioning, and one condition of not good. Next. Next. Yeah. So the condition, the physical investigation shows that the condition is not very good. And also there is a new earthquake map published in 2010 and 2017. So that it raised us the need to do the evaluation of the safety of the dam. However, we have some difficulties in knowing the properties of the material of the dam. So that we conduct the machine boring on 6 locations here at the boring machine number 1 to number 6. Number 1, number 3, number 5 is at the downstream side of the dam crest, and the for machine number 2, 4, and 6 in the upstream side of the dam crest. The boring is performed until the depth of 10 meters. And in every 2 meters, we collect the undisturbed sample, so that we can know the material properties in the dam body. Next. So yeah, it's just one of examples for machine number 1 and number 2, which is number 1 is in the downstream and number 2 is in the upstream. This is the water is in the upstream and the downstream is in the empty one. So we can find here that the material of the dam consists of homogeneous sandy clay with color of brown. But after the head of 4 meters for the bore machine number 1, it shows some sandy clay with grayish brown. It's showing to us that for the downstream side, there is some formation of original sandy clay, which different from the embankment, the brown sandy clay. And we can see here the supposed to be there is some filter between the clay layer and the rock, the riprap of rock, but we cannot distinguish the filter layer. So maybe the filter layer between the rock and the clay already mixed together, become united. Yeah. So next, please. Yeah. And also on the observed phreatic line, the water table observed from the piezometer 1, 2, 3, showing that the water table is decreasing significantly compared to the water table observed during the same time with the observation of the piezometer here. It gives us some information that the water table in the dam's body is decreased due to this homogeneous clay layer in the center, and also the existence of the original hard sandy layer, the grayish brown. So based on this fact, then we conclude that the cross-sectional of the Clayco Dam is something like that, yeah, with the existing hard clay in the downstream part. Yeah. Next. And then for the analysis, we first do the risk evaluation, the total risk factor. It's using the capacity risk factor, CRF, and then the dam height factor, height of risk factor, HRF, and the evacuation need, evacuation risk factor, ERF, and the downstream damage factor, the GRF. Yeah. Based on the data of the Clayco Dam, the CRF is 4 because the capacity is about 2.3 million cubic meters, which is under high value. Yeah. And then the head of the dam is 10 meters, below 15 meters is fairly low, the score is 0. The evacuation need from the damage analysis of the dam, the area that influenced by the damage of the dam is about having the person about 9,000. So here we have 12 score. Yeah, it's more than 1,000 person that are impacted if the damage is if the dam is broken, damage. And also the damage risk factor predicted potential loss is 113 billion. So
maaf Prof, mungkin
factor,
1 menit lagi barangkali.
Oh, 1 minute, okay. Yeah. So it is very high, 28. The next, please. So based on this high risk, so we do the analysis using the OPE and MTE for this return period of the earthquake load. Next, please. And it's the material, the idealist properties of the material that we use, referencing or seeing the result from the boring machine and some data we have. And next, please, the result. Yeah, the factor of safety. Yeah, fortunately, during the normal condition is still over 1.5, and even during the earthquake condition for the OPE load and MTE load, all still over 1.5. So it is safe based on the criteria from the factor of safety. Next. Next, please. Yeah, it shows the result of the QStudio. The conclusion, it is still safe, but during the earthquake of the OPE and MTE earthquake, however, the material that we use are based on bore machine of 6 locations. Yeah, so in fact, give us on more understanding on the material of the dam. And next, and from the seepage, also it is safe. But the recommendation, due to the uncertainty of the material of the dam material, we actually need to do the sensitivity analysis of various variation on the properties of material, and the condition need to be repaired, dam crash, the riprap layer of rock, the instrumentation, and also the operation and maintenance, and also need to restrict the access of society of the people access route and on the dam crash. Thank you very much, Pak Purwanto.
Okay, thank you, Prof. Suharyanto, for your excellent presentation about the condition of glyco dams. I open discussion for the participant. If you have any question to Prof. Suharyanto, please inform us. You can raise your hand or directly use your microphone to deliver your question.
Maybe if participant want to use Indonesian, it's okay, Pak Bro.
Okay, if you shy to use in English, you can use bahasa. Probably it is easier.
Mr.
Okay.
Purwanto,
Okay, yes.
and I ask the
Dengan
question.
Mr. Heri, okay.
Yeah.
Pak Heri, silakan.
Okay, thank you very much for your time. I have 2 questions for Professor Suharyanto. One question is about, because I already take a look from the picture that you saw in the presentation, the dam is to recharge the water, right? So my question is, how to get this water supply in the Glyco dam? It is rely on the precipitation or rainfall or another supply. And the second question is about, you said that there is some, I can say maybe failure about the dam condition, like leveling, settlement. As we know, the dam has many water, so how to repair it? I think the leveling and the settlement, because I think these 2 conditions also will contribute to the assessment, like the safety factor in the dam. That's all my question. Thank you very much.
Okay, thank you, Pak Heri. I think Prof. Suharyanto, you can directly respond to Pak Heri's question.
Yeah, Pak Pur, thank you very much, Pak Pur and Pak Hari, for the question. Yeah, for the Glyco dam, the source of water, yeah, it was initially there is a small river come into the dam, Pak Hari. Yeah, and the catchment area is about 3 kilometers, yeah, 3 kilometers, 3 square kilometers. But at the moment, the small river that flow into the dam is clogged, is buntu, yeah. So I believe that at the moment the source of water is mainly or dominantly from the rainwater. But this year there is some construction work at the inlet of the Glyco dam. They are building the check dam. I I haven't gone there, but I believe it revive the flow, the channel, the river flow to the dam. And secondly, for the repair of the dam crash, yeah, if the damage seems superficial, I mean on the surface, it hasn't come deeper to the dam body, and what they do is to make the resurfacing of the road, yeah, put some quartz layer and make some medium pemadatan, and then to the surface for the asphalt pavement, Pak Heri. All the repair work performed during this year financial year, Pak Heri. Yeah, I think that's all, Pak Purwanto.
Okay, thank you, Pak Prof. Suharyanto. Pak Heri, it is enough.
The continuation about the second question, Prof.
Yeah.
During the repairing the dam, so because there is so many water, so we have to, I mean, to release the water first during the repairing.
Yeah. They do during the hot season, the summer season, where when the water in the reservoir is already low. Yeah.
Oh.
Yeah.
Okay.
Probably in dry season, I think.
In dry
Oh,
season.
in dry
Yeah.
season.
Right. Yeah.
Okay. For the first question, also, Prof. Suharyanto, did you also predict the, I mean, the surface life or something like the, somehow the water is very low in the dam?
Yeah.
Yeah, when? Maybe 20 years later or 10 years later?
Yeah. Okay, Pak Eri. Our prediction may be if there is no some improvement in the catchment area and in the green bed, maybe less than 20 years, Pak Eri. Because the upstream of the Clayco Dam, there are some housing already, some farmers there. So sedimentation is high there. What we are suggesting to do the green belt, the green belt all around the inundation area is planned with some conservation trees, and also to the dredging of the sediment material in the reservoir. Yes, it is not until 20 years to now, because it's already 28 years. Yeah, the design lifetime is about 50 years. So if it is according to the design, will be 22 years again, but it is less than 20 years if the condition is not improved, Eri.
Okay, thank you, Prof. Suharyanto, for your presentation and discussion. Very interesting, informative to us, because we have no time anymore for our discussion. So I think we can continue to the next presenter. Once again, thank you very much. Let we give applause to Prof. Suharyanto.
Thank you very much, Pak Po. Thank you very much, everybody.
Thank you, Prof. Suharyanto.
Assalamualaikum.
Waalaikumsalam. Okay, the next presenter is Mr. Hendrata Wibisana. So for Mr. Hendrata, you ready? You have time 10 minutes, and later we can continue to discussion about 2 minutes. Okay.
Okay, hello everyone. Good afternoon. Today I want to share my research article with you. The title I choose in my paper is Water Quality Mapping on the Coast of Pangkalan Madura based on the acidity value from aquamodis satellite imagery. I share this with my friend Mrs. Seta and Mrs. Kartini from Civil Engineering Department at the same as in UPN Veteran Jawa Timur. Pangkalan Madura is a coastal area that is surrounded by fish pond, shrimp farm, and mangrove area. The coastal area is a home for people who depends on the water creature such as fish and shrimp for their livelihood. Therefore, the ecosystem problems that might be caused by water quality issues, such as water pollution, could affect their fishery products. The purpose of this study is to analyze water quality in the Pangkalan Coast by mapping the acidity distribution of the coastal area using the aquamodis satellite imagery. And this is the operation about the scene of the image of satellite. This is the whole scene or full scene, and then we done with the scene cropping, and the final process is like this. As you can see in this picture, we can crop with this location at Bangkalan. And this is the coordinate longitude, latitude with the parameter. We choose the acidity or pH. And you can see in this table, we choose 20 sample from the area like this. To illustrate the distribution of pH value on the coast, the study implemented the two most optical mathematical model algorithm as indicated by the accepted R prime value of other models using CDAS 7.5 software. It concludes that acidity distribution which is processed using a wavelength of 667 nanometer has the best results compared to the other. This is the resume, the algorithm from mathematical model. Algorithm like linear, exponent, logarithmic, and power. As you can see, this is the final result of the model, and the best result is the exponent with the R prime 0.779. Validation test result for each mathematical model. This is, you can see the graphical scene with the 5 series. In in situ, linear, exponent, logarithmic, and power. We can combine each other. As seen in figure, the pH value of each mathematical model has a slight difference compared to each other. After the pH value of the fields, data is processed using algorithm calculation of satellite image data. The mathematical models that can represent the situation of Bangkalan, Madura coast weather were obtained. However, an advanced correlation test is still required to identify their correlation to each other. And this is the correlation table. As you can see, compare from in situ with the others model, linear, exponent, logarithmic, and power. And we can see that the in situ is the higher correlation with exponent 0.9059. As you can see it is. So we can choose the exponent algorithm to make a thematic map of acidity value in the area we choose is Bangkalan. As you can see here, thematic map of acidity using the exponent algorithm at 667 nanometer wavelength. This is the color of the acidity from map. And the ring between blue and red. As a conclusion, Aquamodis image data can be used as a reference to identify the mathematical model algorithms that able to calculate any parameter such as the acidity or pH value of the coastal water environment. This study concludes that the distribution of acidity in the Bangkalan coast is still within the safe pH range for aquatic ecosystem on the coast. Okay, thank you very much for your cooperation.
Okay, thank you Pak Hendratata for your informative and very informative, excellent presentation. We have about 3 minutes for Q&A. Well, please, any of the participants who has question, you can directly turn on your microphone. Okay. While waiting, probably I want to ask you one question, Pak Hendratata. You have a research about pH value, isn't it?
Yeah.
So I wondering whether have problem in the Bangkalan coast related to pH from maybe from fishermen about his he doesn't have enough fish to catch or something. Mungkin
Okay.
ada ya.
Yeah. In the field, I use a small pH meter, like pH meter digital. We can calculate suara mendengung.
Mendengung Pak, dikecilkan apa?
Okay. with the pH value, we can know the acidity of the sorry, the sound is not good.
Mungkin dikecilkan biasanya Pak. You can turn off the.
Okay, so the pH need for the water body in the coast of Bangkalan, because the higher pH, the biota like fish no longer live, and low of pH the same. So we need the standard pH in the environment standard, like 7.1 until 7.9. This is the standard for the health of water body constituent, like this.
Okay, thank you Pak Hendradata. So this research is for to know the condition of the environment related to the standard, I think. Is it correct? Yes.
Yeah.
Okay, thank you, because we have not enough time. Thank you very much, Pak Hendradata, for your presentation. Please, we give applause to Pak Hendradata.
Thank you.
Okay, we continue to the next presenter. We have here Bapak Iwayan Koko Suryawan.
Mr. Purwanto.
Yes.
My name is Ifraini Rifa. I am the representative for paper ID 106,
Okay.
Iwayan Koko Suryawan, because Iwayan Koko cannot couldn't attend this session. Okay, Bapak.
Okay. Bapak siapa tadi?
Iwayan Koko.
Iwayan Koko.
Yeah, multi-attribute the paper with title in multi-attribute analysis.
Oh, the presenter is Ibu Iva.
Yes.
Okay.
Yes.
Yes.
The presenter is.
Okay. You can continue to your presentation. Your time is about 10 minutes, and we can continue to discussion.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Almira Davina Nastiti from Pertamina University. Today I would like to give presentation about multi-attribute analysis of rainwater treatment from deep wells at PDAM Tirta Mahotama, Klungkung Regency, Bali. And here's the outline for today's presentation. The first one is background. PDAM Tirta Mahotama is a PDAM located in Klungkung Regency, Bali Province, which serves 4 sub-districts and has 21 deep wells, 7 springs, and 1 reserve seawater osmosis treatment unit as the water source. According to the 2019 PDAM performance book, PDAM Tirta Mahotama had received health category with customers' water quality aspect value of 88%. However, this value is still included in the 3 lowest scores compared to the other PDAM in Bali Province because it has not reached 100%, which show that it has not been maximal or has fully met quality standard. This show from the water quality from some deep wells that still exceed the quality standard. And based from that, the study aims to find and develop the right technology selection to improve quantity and quality of deep wells in Klungkung Regency. The next one is method. The data used in this study is from monitoring the deep well quality of PDAM Tirta Mahotama, with the parameter measured were physical parameters such as odor, color, TDS, and taste, and chemical parameters such as aluminum, iron, hardness, chloride, manganese, pH, sulfate, and ammonia. The selection of alternative is carried out using the multi-attribute utility theory or MAUT method. This method is a method of decision-making by considering more than one criterion. This method has often been used in various fields to assist decision-making, including management, environmental management, economics, and engineering. Next is result and discussion. The first one, reliability of raw water source. The Table 1 show the characteristic utilization of raw water from deep wells in Klungkung Regency. There are 21 deep wells utilized with a total production discharge of 164.5 liter per second. The availability of deep well water drops dramatically during dry season. The production process only consists of taking water from the well through a submersible pump and disinfection using chlorine gas. Then the water is directly distributed to customers. The disinfection process is carried out by injecting chlorine gas directly into the distribution pipe. However, some deep wells still have some parameters that exceed the quality standard. Next is water quality. Table 2 showed that the predominant parameter is aluminum, followed by color and TDS. But for this study, no further discussion was carried out for the TDS parameter since deep well in Nusa Penida area, where the excess of TDS occur, already have a distillation unit to process the excess of TDS. According to the Permenkes number 492 of 2010 concerning drinking water quality requirements, aluminum's full drinking water content is 0.2 mg per liter. And as shown in table 2, most of the deep wells exceed the quality standard. Excess aluminum content in the body can cause neurological disease, while the presence of color will interfere with the water aesthetics and indicate polluted water. The next one is water treatment decision analysis. Table 3 shows the consideration used in the selection process. The design unit determination is done through a literature study by looking at previous research on aluminum removal and color. The PDIM wants processing that is as simple as possible and does not require high cost. Therefore, several considerations were made to choose a design alternative. At this stage, the selection unit will be varied in processing methods, materials, or configurations for further evaluation using Mauth method. The description of alternative has been discussed in the previous discussion that will be proposed 3 alternative processing, namely adsorption using granular activated carbon adsorbent with the fixed bed adsorption column, adsorption with silica adsorbent with fixed bed adsorption column, and adsorption with powdered activated carbon. After the weight value for the qualitative criteria is determined, a summary is made of all the measures value for alternative as shown in table 4. The utility value is calculated on each criterion for each alternative. This utility requires quantified criterion value data. Relative weight calculation is carried out on each measure based on the value of the level of importance. The calculation result can be seen in table 5. In calculating the final evaluation, the utility value data and the weight normalization of each criterion are needed. Based on the analysis using Mauth method, an alternative ranking was obtained for the deep well as listed in table 6. Based on the analysis using Mauth method, adsorption with granular activated carbon adsorbent was chosen as the best alternative in the well. Figure 1 shows an example of a circuit used from a fixed bed adsorption column in a deep well in Klungkung Regency. The water will enter through the influent distributor and will undergo adsorption in the absorption zone and flow through the under-drain system as an effluent. The spent water drain tank tube helps store carbon during backwash to be cleaned, and then after cleaning the carbon, it will be regenerated using furnace. After selecting the best alternative, detailed planning should be carried out regarding the granular activated carbon processing implemented in Klungkung Regency. The last one is conclusion. From the study, we can conclude that water discharge produced from each deep well in Klungkung Regency is around 1 to 9 liter per second, and based on evaluation using Mauth method, fluidized with granular activated carbon is chosen as the technology to improve quantity and quality of deep wells in Klungkung Regency. That's all from my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the presentation. I give opportunity to all the participants. If you have any question, you can directly deliver your question.
Pak Pur,
Okay.
may I?
Silakan.
Yeah,
Monggo.
thank you, Pak Pur.
Okay.
I would like to have a question to Iva. In the analysis, do you put any weight in its criteria or the weight? It seems that you have equal weight, yeah, to its criteria, yeah.
Yes, Prof.
Thank you.
Yeah. Thank you, Prof. Suharyanto. From asking question, I want to try to answer. Yes, this research joined with the University of Pertamina because we know about the background for the quantity and the quality of raw water from the deep well is not fulfill the requirement for utilization for society utilization. So in this paper, we use the multi-attribute analysis of raw water treatment with the 6 criteria. Like we must know about the technology for the treat or for the process, the quality of water that we must to improve, and then we know about the cost because PDAM in Bali need the technology for treatment water in PDAM that low cost, and then we must know about the material and the design that used to treat the water like the absorption, and then wait, Prof. Absorption, and then granular filtration and precipitation. And based on the evaluation using this method, that fluidized bed granular activated carbon is chosen as the technology to improve the quantity and the quality of deep wells in Klungkung Regency.
Okay.
Yes, Prof. Suryanto.
Okay, yeah.
Maybe
So
any other question?
Yeah, you use equal weight, yeah, for its criteria, yeah. You
Yes.
have 6 criteria, they have
Yes.
equal weight, yeah. Okay.
Yes, I compare the 3 technology through add the jumlah quantity and to improve
like
the
the
quality.
criteria for color removal is similar weight to
Yes,
the
for color
cost,
removal.
yeah, similar
Yes.
to the weight to
Yes,
the
we
aluminum,
focus.
yeah. Okay.
Yes, Prof. Suharyanto, we focus on the predominant parameter, color, and aluminium, because color contain the inorganic, and then from the metal that make the water is not good for the quality to utilize our need, yeah, in.
Okay. Yes.
Yes.
Thank you, Bu Iva.
Okay. Thank you, Pak Suharyanto. So
yeah,
the highest
from the question.
the highest score for criteria is for the removal of aluminum and color,
Yes.
I think, isn't it? Okay. Thank you.
Yes. Thank you, Mr. Purwanto, for guiding me.
Okay.
Yes.
Okay, I think it's enough for the session. We can continue to the next session. The next session is also from Pak Yoyan Koko, who will present it right now.
Hello, Mr. Purwanto. So I will represent Mr. Koko again.
Oh.
So I'm in the part of the team, so I will represent Mr. Koko because he's on teaching now.
Okay. Ibu Intan, yeah.
Yeah.
Ibu Intan
All right.
Rahmalia. Okay,
Yeah.
thank you. Please, your time is about 10 minutes, and then after that we can continue to question and discussion.
Greeting for all ladies and gentlemen. On this 5th International Conference, Rehabilitation and Maintenance in Civil Engineering, allow me, Intan Rahmalia, to represent a team from Pertamina University to present a paper with the title of Determination of Produced Wastewater Treatment System for Reclaiming Water in the Oil and Gas Industry. Our team consists of 6 people, which are Novena, Nurul Baiti, Arianti, Intan, and Iwayan, who come from Pertamina University, and Iva come from Universitas 11 Maret. The discussion will divide it into several subtopics. The first subtopic describes the background of research. The second subtopic describes the methodology that we use in the research. The third subtopic describes the result and discussion. And last subtopic is the conclusion. First, the background. Oil and gas industry often produce the water that contain hydrocarbon from their exploration activities in the upstream, which known as the produced water. According to the Hayes 2010, oil and gas industry produce 80% produced water. This significant amount can be used for irrigation, wildlife consumption, etc., by processing it in the unit treatment, so that it can meet the quality standards. In terms to produce water that can meet the standard, the water treatment process will carry in the 2 stages, which the primary treatment and secondary treatment. The primary treatment aims to remove oil and grease by using the gravity suppression method. Therefore, several technologies are proposed. First, American Petroleum Institute separator. Second, parallel pad interceptor. Third, corrugated plate interceptor. The secondary treatment aims to processing other constituent in water to reach the quality of desired effluent. Therefore, several technology processes are proposed. First, membrane technology. Second, coagulation. Third, biological processing. For secondary treatment, I prefer to use the physics-chemical process because it needs small area and operational simplicity. Therefore, this research will determine the most appropriate treatment unit for reclaiming the produced water. Second, the methodology of research. First, the location. This research is obtained at Lindai Gathering Station, which belong PT Pertamina Hulu Energi Kampar Siak. The area is shown by the orange line in the Google Earth picture, and the area of existing water treatment plant is shown by the green line. Next, the produced water quality. In this research, the parameter used as the object to analyze are come from the Environmental Management Plan and Environmental Monitoring Plan document 2016 until 2019, which the chosen parameters are point to the Ministry Environment and Forestry Regulation number 19 of 2010. The parameters are chemical oxygen demand, oil and grease, temperature, pH, and total dissolved solid. Last is the decision method. In this research, analytical hierarchical procedure method is used to determine the best wastewater treatment unit with 5 assessment criteria, which consists of removal of oil and grease, the effectiveness of eliminates the COD, operation and maintenance, land requirements, and the initial cost of processing unit materials. The criteria will be assessed and compared in pair to determine which standards are prioritized in the several processing units. Third, the result and discussion. In existing condition, Lindai Gathering Station treats the produced water using a storage pool called pit. There are 4 pits in Lindai Gathering Station, which function to reduce the temperature and oil levels in produced water before being forwarded to the Lindai River. Also, the produced water are processed to meet the third-class raw water quality standard in Government Regulation Number 82 of 2001, and this will be used for watering plants. As the part of the analyzing the characteristic of water, the produced water quality will be compared to the effluent quality standard. Based on the table 1, we can see the parameter COD and oil and grease are not meet the standards. So both parameters are being concerned in this research. From figure 1, we can see there is several alternative manufacturers for the series of produced water treatment unit to be proposed. The difference between the three series of treatment unit is in the oil and grease removal technology, which are CPI, API, and PPI. The main goals of water treatment is to remove the content of oil and grease in the water. So in the process of deciding which treatment unit will be selected, the criteria of oil and grease removal efficiency is being the critical judgment and must to be prioritized from the other criteria. And that is why oil and grease removal is having the highest score compared to the other criteria. On the other side, the criteria of operation and maintenance is being more prioritized. Then the needs of the efficiency of COD removal, land requirement, and cost. This having a score of 3. The criteria for land requirement is being more prioritized than the needs of the efficiency of COD removal and cost. This having a score of 3. Last, the needs of the efficiency of COD removal is being more prioritized than the amount of the initial cost of processing unit materials. This having a score of 3. After analyzing each component of each criteria, then we can get the value of eigenvector that's shown by the table 2. Last, the assessment of the comparison of each alternative with each criteria is shown by the table 3. The selected processing unit alternative is CPI with weight 0.51 or 51%. Thus, based on the AHP analysis result, CPI unit are chosen to treat produced water from Lindai GS as the primary treatment and reprocessed to secondary treatment by using ultrafiltration membrane technology. The effluent will be used for watering plant, and for the schematic diagram and mass balance of water treatment is shown by the figure 2. Next is the conclusion. The reclamation of produced water from the upstream activities in the oil and gas industry is carried out using a CPI unit and ultrafiltration that's selected based on the analytical hierarchical process method to eliminate high oil and grease and COD from high oil and grease and COD content from the water. This is the reference that we use. That's all from the presentation, and thank you for your attention.
Okay, thank you, Ibu Intan, for the presentation. I invite the participant to deliver your question. Okay, yes. Do you want to have question? Probably I have one question for Ibu Intan. I noticed in your slide that the water is after treated, it is discharged into Lindai River, isn't it?
Yes, correct.
Okay, Lindai River. So because we should also know the situation of the river. Do you consider the quality of the Lindai River? Because before you discharge the wastewater into a river, you should also consider the quality of the river.
All right, thank you for the question, Mr. Purwanto. So I will answer the question. Thank you for the question, by the way. For the Lindai River, we know that this gathering station is having a location besides of the river that we name as the Lindai is the name of Lindai is the name of location in that place. So the river actually so basically this location is located in the middle of a jungle. So there is no really crowded population in there. So if there any like pollution or something like constituent to be discharged in this river, it is only comes from the Lindai gathering station activities. So we know that this river already have like the good quality, like based on our research, this Lindai River are not polluted with other constituent like high polluted not, but because of that, we have to be concerned about the effluent of this activity primarily because this is the activity of oil and gas. So we must consider the effluent that discharge on this activity. Which is we know from the result from the laboratory analysis that the oil and grease and COD having a very high content. So we must consider this before being discharged. So these rivers are not high polluted because this is located near or in the middle of a jungle. So there is no really crowded population in there. So if there any pollution, it is only comes from these activities. Is it already answered the question?
Thank you, Ibu Intan.
Mr. Purwanto, I will now ask to Ibu Intan. Yes. What is the characteristic of produced wastewater that take from the oil and gas industry in Lindai? And then in the conclusion, what is the best system for reclaim produced wastewater in that place in Lindai oil and gas industry?
Okay, thank you, Ibu Ipa.
So I will answer the second question for the characteristic. If not wrong, please correct me if the answer is not really point to. So the characteristic on this, our analysis are based on the 6 parameters that are mentioned in the Ministry of Environment and Forestry number 10, which is already mentioned in the slide. So based on the 6 parameters, we know that COD and oil and grease having a really high content that we know if this is the content, if we are discharging to the river, it will come up to the alga blooming and also and also having like greasy water in the river. So we must avoid that condition by treating it using the CPI unit.
So contain high organic carbon. Yes.
For the COD, we are treating it by using the ultrafiltration membrane, which is we are using we are not using the coagulation or the
Spirit the in a chain, yes. A long chain for the produce wastewater.
Yes, correct.
Yes, thank you, Bu Intan, for the explanation, for your explanation.
Yes.
Thank you, Mr. Purwanto, for this
Okay.
opportunity.
Thank you.
Thank
you
you
for the
to
question.
Eva. And then I think the time is already enough for this session. Thank you, Bu Intan, for the presentation and the nice explanation. We will give applause to Ibu Intan. Okay, we can continue to the next presentation. The next presentation will be delivered by Ibu Imro'atus Solihah. For Ibu Imro'atus Solihah, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, the honorable all participants who attended in this conference. Let me introduce myself. My name is Imro'atus Solihah, and I am a representative from Pertamina University. Today, I would like to present a paper. The entitled is Preference of Sludge Treatment Plant in IPA 2 Pejompongan Water Treatment Plant. And this is my outline. First is background, and the last is conclusion. Next is background. IPA Pejompongan currently has no sludge treatment, where the treated sludge is discharged directly into the surrounding water bodies. The name is Crooked River. Discharge of mud into rivers can damage the river aesthetic and endanger the aquatic biota in it, because increased turbidity in water bodies will interfere with sunlight penetration, which will then block the photosynthesis process. Therefore, the goals of this paper are to determine the existing condition of sludge treatment at IPA 2 Pejompongan and to determine the appropriate alternative for sludge treatment based on the characteristic of the sludge in IPA 2 Pejompongan. And the location of this research at IPA 2 Pejompongan, South Jakarta. Next is data and method. This is the existing mass balance of sludge production water treatment at IPA 2 Pejompongan. The sludge sampling method is area integrated. That is by combining the sample taken from the pre-sedimentation valve or primary setting and the pulsator. And this is data from IPA 2 Pejompongan from January until December 2019. From figure 1, we can see that the most significant sludge discharge comes from the pulsator, because the most significant allowance for suspended solid is in the pulsator unit. In January until June, the resulting mud flow is greater than July until December, because in that month, the rainy season occurs in Jakarta. And in table 1, we can see the characteristic of sludge produced in the primary setting unit and pulsator at IPA 2 Pejompongan. There are density of sludge, solid level, and contribution to total sludge at IPA 2 Pejompongan. Next is sludge quality data. This is comparison of sludge quality with standard in Jakarta, and the regulation is regulation the governor of the Special Capital Region of Jakarta Province number 69 of 2013. Next is the method. In this journal, in this paper, using 4 alternative mechanical dewatering units, that is bare filter press, centrifuge, screw press, and pressure filter press. In selection alternative sludge treatment plants, the parameters that must be met are land area and electrical energy requirement. The available land area is 1,300 meters square, and the maximum electrical energy that can be used for a sludge treatment plant is 100 kilowatt. Based on these 4 mechanical units, that the require more than 100 kilowatt of energy are centrifugal and pressure filter press, so that the alternative option to be considered are the bare filter press and screw press. In the figure 2, you can see the schematic diagram of alternative sludge processing with bare filter press and screw press. And for the processing data, we use Topsys method. Topsys is the method that can determine the best alternative from several alternative solutions with various criteria. This is the equation. There are positive ideal solution, negative ideal solution, and the preference value. The key point of this method is the greater the preference value, the smaller the distance to the positive ideal solution, and the further away distance to the negative ideal solution. The value of greatest preference will be the chosen alternative. And this is the Topsys data processing results between bell filter press and screw press. The result is that the screw press is the alternative with the highest preference and will be the best design alternative applied in IPA 2 Bejompongan. Why screw press? Because screw press it is closer to the positive ideal solution and also further away from negative ideal solution than bell filter press. And so the conclusion that the results of the best alternative selection analysis show that the screw press can be used as such treatment at IPA 2 Bejompongan. And before using the screw press, pre-treatment in the form of gravity thickening and semiconductor condition is required. And this is the references we use in this paper. Okay, that's all from my presentation. Thank you for your attention.
Thank you, Ibu Imro Ato Solihah. I invited all the participants to have a discussion.
Yes, Mr. Purwanto.
Okay, yeah.
Can I give the question for Ibu Imratus?
Please.
Yes, thank you for this opportunity. Ibu Imratus, I want to ask about the what is the difference treatment from the screw filter, yeah, bell screw filter tadi, filter press with the gravity technique. Ibu Imratus, yes.
Okay, I will thank you for your question. I will answer that the function of the gravity thickener is to reduce the water content of sludge, and for the screw press is to pressing the sludge until cake solid.
Okay, so after the water content is reduced and then make the solid, yeah, for to AC for the in the disposal.
Yes, Miss.
Yes. Thank you, Mr. Purwanto.
Okay, thank you, Ibu Ipa, your question. Is there any question from the participant? We have still some time, several minutes for the discussion. Okay, if there is no other question, I think it is enough for Ibu Imro Ato Solihah. Thank you for your presentation. Please give applause to Ibu Imro Ato Solihah. Okay, we can continue to the next presentation. The next presentation will be delivered by Bapak Mahdika Putra. Oh, Bapak Mahdika Putra, the time is yours.
Good morning, ladies and gentlemen. Thank you for coming to this presentation. It's great to see you all. I am Mahdika Putrananda, a recipient of 5th International Conference of Rehabilitation Maintenance in Civil Engineering. I will present my research entitled The Evaluation of Irrigation Maintenance in Partial Irrigation Area at Bojonegoro Regency, East Java. First of all, there is introduction in this research. Water is a vital natural resource that supports a lot of sectors in life. This element is highly needed, especially in the agricultural sector, where the water supply supports most of the production. This sector then requires good water management to fulfill all the water needs. If the water availability is not adequate, another solution is made to still fulfill the water need. Water scarcity is a challenge due to increasing demand from various sources ranging from agricultural, mining, industry, hydroelectric power, and the increasing human population, especially in rural areas. The need for irrigation water is very important for agricultural land. This research then aims to investigate the physical condition of partial irrigation to function optimally the kind of maintenance that can help increase the irrigation performance. And then for the research method that used in this research is a descriptive method to explain the variables. In principle, descriptive research does not aim to form hypotheses or theory development. The characteristic of descriptive research is objectivity or neutrality. In this research, primary data was the basis that determines the physical condition of partial irrigation. Then, after knowing the data under existing condition, the type of maintenance and development for the irrigation can be determined to increase its function as the agricultural production support. The research data is presented in the flow chart below. This is a flow chart of the research method. For the result and discussion in this research, survey and the documentation of partial irrigation were taken throughout the canals of 12.48 kilometers of Lepak to Mercury's Weir. It also was taken from 8-kilometer canals of Mercury's to Kerjawir. Partial irrigation area consists of 16,624 hectares of agricultural field. Throughout canals, maintenance was indeed needed, such as clearing the weed on the canal wall and fixing the created wall that can disturb the streamline of water. It seems in figure as seen. The first picture on the left side is indicate the presence of weeds on the canal wall, and then the second picture on the right side is damage to the channel wall. Next, the investigation through GPS and Google Earth is used to facilitate the damage tracking and inventory process. Picture below show the map to the track location in partial irrigation as seen below. After the investigation, the results show the damage to partial irrigation infrastructure. The evaluation is based on Minister of Public Works and Public Housing Regulation number 12 of 2015, where the physical condition index is presented in table as seen below. Based on the result above, partial irrigation infrastructure condition can be determined. According to the table above, it can be seen that the damage of partial irrigation main infrastructure is 4.40%. It came from a lot of components such as a reservoir/sensor and waste gate. On the other hand, the damage of 7.40% happened in canals and 0.75% in canal structures. The total damage in partial irrigation infrastructure is 12.55%, showing a minor level of damage. The major level is less 40% for the damage. The moderate level is 21 up to 40%, and the minor level is 10 up to 20%. Compared to that, less 10% percent level means the irrigation is in good condition. Partial irrigation infrastructure damage is presented in a bar chart as shown. Requirements for the maintenance of the irrigation scheme of each the irrigation area must consider the performance of the irrigation area in the aspects of the physical infrastructure condition of the network and other supporting aspects. The conclusion in this research from the analysis above, it can be concluded that physical damage of Pachal's primary canal is 12.55%, indicating a minor level of damage. Meanwhile, for the area's network and infrastructure, regular maintenance was needed to ensure the irrigation performance ran efficiently for watering the agricultural field. That maintenance could be in the form of cleaning the weed that grew uncontrollably around the canals, plastering the cracks of the broken canal walls, lubricating the hinges of sluice, coating the sluice gate with anti-corrosion paint, and change the last of broken wood. That's all of my presentation today. Thank you for your attention.
Oke, putus ya? Oh, sudah selesai nih. Have you finished, Mr. Mahdika? Oh, I think because Mr. Mahdika is not present in this presentation, so we have no question and answer session. So we can continue to the next presentation that will be delivered by Ibu Ratna Utami.
Yes,
Okay, for Ibu Ratna Utami, the time is yours.
thank you. Good morning, ladies and gentlemen. My name is Ratna Utami Agung Wiono. Today I will present our research entitled Wind-Generated Wave Simulation Utilizing Delft3 in Payangan Beach, Jember, written by Enggar Setiabaresi, myself, and Dwi Yunarni Widiati from Civil Engineering Department, University of Jember. Almost every year, high waves occurred in Payangan Beach, usually on July. Here we can see two examples of documentation on July 25th, 2019, and also on May 27, 2020, waves damaged houses and also small shops in the Payangan Beach. So it is necessary for us to study and simulate high waves in Payangan Beach, especially in these 2 years. In this flowchart of our research, the first step is data collection, which is bathymetry, wind data, and land boundary data collection. After that, we conduct the preparation of input file, then the calibration by simulating high waves on July 2017. And if calibration is okay, we continue with simulation for high waves in 2019 and 2020. And the final step is analysis, including the structural measures design and conclusion. Wind data of this study was obtained from Class 3 Meteorological Station in Banyuwangi, which is the closest station to the study site. And also we use the spatial variation of wind data. It is from Climate Data Store Copernicus data. For the bathymetry data, we use the bathymetric data from Indonesian Geospatial Information Agency. And this is the bathymetric data, and the simulation grid size shown here with the size variation from 50 meter until 200 meter. Payangan Beach is located here. It is at the southern coastline of Java Island. This is the simulation that the results that we obtained in 2017. If we compare the simulation results, the red dashed line with the observational data, the blue line, we can see that both data shows quite similar trend. The right panel shows the significant wave height on July 25th, 2017, and in the coastal area, the significant wave height ranged from 2.5 meter to 4.5 meter, the coastal area. So because the high wave, quite high wave, that is the cause of the coastal flooding that we see in the second slide. So it is confirmed that the simulation could reproduce the observation data. About the simulation results in 2019, it is found that the simulated wave height much higher than the one that simulated in 2017. The outstanding high waves also confirmed by captured the video here. Although there are still discrepancy between simulation and observational wave height, that may be caused by the quite small resolution of simulation grid. In 2020, the simulated wave height and the observation data reach almost the similar results. And different from the simulated wave in 2017 and 2019, in 2020, the high wave occurred not in July, but 2 months earlier, which is in May. In this slide, we try to make an illustration what the differences between the condition of houses with and without seawall. If there's no seawall, then the high waves that propagate from the ocean to the beach, it will inundate the houses. But when the seawall is developed here, then wave will stop by the seawall and it will not inundate the houses. So it is necessary to build the seawall as safety measures based on the simulated wave height. But once the conclusion of this study, high waves occurred at Payangan Beach is significantly high because of direct exposure of wind and wave from the open ocean. The simulated result in 2017 shows significant wave height of 2.5 meter to 4.5 meter near shore and around 5 meter offshore. However, in 2019, wave height reached 6 meter to 7 meter in near shore of Payangan Beach, and also in 2020, high wave occurred 2 months prior than other years, which always occurred in late July, and that may happen because of the climate change, and the preventive measures must be taken into consideration to protect the coastal area and residential area located in Payangan Beach. Thank you.
Okay, thank you, Ibu Retno, for your excellent presentation. So next, I would like to invite
Good morning, ladies.
the participant. If you have any discussion, refer to Ibu Retno. If there are no any question from the participant, I think I have a little bit question to Ibu Retno.
Yes.
So I noticed that in your slide you compare between the observed wave height to the simulated wave height. But I also noticed that your simulation area is very wide area, and in what location the comparison of your simulated and also the observed wave height, in what location? It is average or in specific location? Because wave height is distributed, right, in your areas of simulated area. Do you understand what I mean?
Okay, thank you for the question. Yeah. Could you hear my voice?
Yes,
Okay, thank you.
I can understand.
Yes, actually the simulation was conducted in Payangan Beach. It is in the south coast of
Yes.
Yes, and the observation data also taken in the same location. It is based on the series Copernicus data. So it is a spatial variation of wind. Then we took the observation data from that series Copernicus for the same day. So it is actually the graph. If we see the x and y direction, direction is the x1 is actually time series variation. So we simulate 1 full day from 0 to 24. So for 1 day, we simulate the wave for that specific location, and we compare that simulated one using the 3D wave and compare with the CDS Copernicus data. So that is.
So the location is in Payangan, in coordinate, in one coordinate. So it is the comparison in one coordinate.
Yeah, so it's not one specific coordinate, but it is, we have an area. So if we see in the slide, you can see that there is a simulation domain. So we compare the similar location.
Okay.
Simulated and observation one.
Because it is, I think, quite difficult to have data for one specific coordinate. It's usually in one area, isn't it?
Yeah. I mean, I understand. The one that I show in map, that is the one with for that simulation domain. But for the graph itself, we choose one point within the the domain. So we actually, what we choose is the area where probably the high waves happen from that video and also from the photo that we have. Then we choose maybe where is the location that could be the highest one. So we choose that location, then we compare that simulated and observational data.
Okay, thank you, Ibu Retno, for your clarification.
Thank you.
Because I don't have experience in simulation with Delta 3D, but I think I have once using Delta 3D for simulation tidal wave, but not for the
wave,
short period wave.
Yes. This one.
Okay.
Thank you.
Thank you. Is there any question to Ibu Retno? I think your name is, remember me, my former teacher. Pak Agung, is this your father?
Yes.
Yeah, okay. Please send my warm regard to Pak Agung.
Thank you.
If no questions, so we can continue to the next presenter. The next presentation is Ibu Retnayu Mulya. So Ibu Retnayu Mulya Please present.
Hi, hello everyone. Assalamualaikum warahmatullahi wabarakatuh. Dear speakers, dear viewers, the committee, and all participants. I am co-author here to present my paper with the title is Infiltration Wells as an Alternative Eco-Drainage System, a case study in Mangkumen, Surakarta, and the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering, ICRMCE in Surakarta, Indonesia. Before I start my presentation, let me introduce myself. My name is Retna Maria, and I am the co-author here. The second author is Mrs. Idris Hadiani, and the third author is Mr. Adi Yusuf Mutakin. We are from Universitas 11 Maret, Surakarta. This research started from public complaints about the frequent occurrence of inundation during the rainy season in Mangkumen. Mangkumen is one of the villages located in the center of the city of Surakarta. The population that continues to increase and the development of the trade and services sector makes land that was originally open to be built up. This, of course, will have an impact when the rainy season arrives. In addition, the drainage system in Mangkumen village still uses a conventional drainage system in which all runoff will be transferred into the channel. Of course, from year to year, the channel will end its service life so that it is no longer able to accommodate the runoff. The solution to this problem is to absorb water back into the ground by using infiltration wells as an alternative to an eco-drainage system. The concept of eco-drainage system is to maintain the existing channel so that the infiltration well will be placed at the bottom of the channel with the assumption of the research is that the drainage channel is rainwater drainage. The main objective of this research is to determine the reduction of runoff by implementing infiltration wells in Mangkumen village. In this study, I conducted a survey of drainage canal tracing to obtain the existing condition and capacity of the channel. Next, I used the rational method to calculate the return period of peak discharge. The return period of peak discharge that I use is 2 years and 5 years for residential area and urban area. Furthermore, to find out the Indonesian area resulting from the peak discharge, I used software named HECRAS. And lastly, I used the Sunjata method to calculate the dimension and the absorption discharge that occur. The first result is the total capacity of the drainage canal can accommodate the runoff discharge at 62.0599 cubic meter per second. The next is peak discharge. The peak discharge in return period is calculated by using rational formula. The peak discharge in return period 2 years is 18.2089 and for 5 years is 22.9937 cubic meter per second. And here is the height graph of peak discharge using rational method. And next is about the running HECRAS. The peak discharge for the return period of 2 years and 5 years is inputted into HECRAS, and the output is the map of inundation and the areas of inundation because of peak discharge 2 years is 25 hectares, and because of peak discharge 5 years, the areas is 28 hectares. And about the channel capacity, about the peak discharge of return period 2 years, the channel capacity can accommodate the runoff, but in the peak discharge 5 years return period, the channel capacity cannot accommodate the runoff, and there is an inundation. And here we go to infiltration wells. The depth and absorption discharge of the infiltration are calculated by using Newton's formula. And here I have two alternative infiltration wells. The difference is the diameter and contraction. The first alternative I use is PVC pipe construction with a diameter of 16 inches. The second alternative I use concrete construction with an inner diameter of 30 centimeters. And the reduction of the alternative 1 is 5.4%, and the rejection of alternative 2 is 2.8%. And here is the cost per well, and the alternative 1 is high PVC construction, cost 800,000 rupiah, and the alternative 2 using concrete wells, and the cost is 89,000 rupiah. And the last is about the conclusion. First, the existing channel's capacity is able to accommodate runoff due to latent period discharge 2 years, but it cannot accommodate the runoff due to period discharge 5 years at 906.42 cubic meter. The second, there are two alternatives of infiltration wells. The alternative 1 can reduce the drainage load at 5.4%, but costs 800,000 rupiah per wells. And the second alternative can reduce the drainage load at 2.8%, costs 89,000 rupiah. And the last, the dimension of alternative 1 are diameter 40 centimeters and height 1 meter, and space between well 2 meters, 1 meter, and space between wells 2 meters, and the number is 4,221 holes. The dimension of alternative 2 are diameter 30 centimeters and height 1 meter, and space between wells 2 meters. And that's all my presentation. Thank you for your great attention.
Okay, thank you very much, Bu Ratna Yumulya. So very interesting presentation. I invited participant, if you have any question, please you can directly turn on your microphone.
Yeah, I want to ask some question.
Okay, dengan Bapak
Farhan.
Farhan ya, oh, okay. Please, Mr. Farhan.
First question, how do you know that the channel is drainage channel? And the second question, why you place the wells in the bottom of the channel? Thank you.
Okay, thank you, Farhan. Please, Ibu Ratna Yumulya.
Thank you, Mr. Purwanto, about the opportunity, and Mr. Farhan about the question. Based on the survey, the existing channel is a rain drainage channel. The first, there is no wastewater sewage pipe into the channel, and the second, channel is an open drainage, clean from wastewater. And the third, in the dry season, there is no water in the channel, so it can be inferred that there is no wastewater in it. And the second question, why I put it on the bottom of the channel, because the area is full of settlement and concrete surface, and almost has an public open space. And if we enlarge the dimension of the channel, it causes the road can be narrower, because it is the local road, so that you can pass even 2 vehicles on it. That is, Mr. Farhan. Thanks for your question.
Yeah, thank you.
Okay, thank you, Mr. Farhan, for the discussion. Is there any question? More question?
Excuse me, I have a question.
Okay, Mr. David.
Thank you for the opportunities. I have a question to Ms. Ratna. I saw that you used 2 alternatives, concrete and PVCs. Do you have any reason why you choose these 2 alternatives? Thank you.
Okay, thank you, Mr. David.
Thank you, Mr. David, for the question. Yeah, I have 2 alternatives on it. PVC construction and concrete as well, because both have their own advantage. The first one is PVC construction. The advantage is it is easy to be applied and it has a hard material, so it can be stronger, but it costs more than the second one. And the second one, it is cheaper from concrete bus, but it is less in capacity. So from two alternatives, the conclusion is it is easy to be applied. So that's it, Mr. David.
Okay. I think it's enough, Mr. David. Okay. Thank you, Mr. David, for your discussion. I think it is the end of our session. So please give applause to Ibu siapa tadi? Bu Retnayu Mulya.
Thank you, Mr. Purwanto.
Okay. Ibu Retnayu Mulya is the last presenter of this session. So I will close this the first round of parallel session. I would like to thanks to all participants, especially to invited speaker, Professor Suharyanto. Thank you very much for your presentation and also your knowledge that has been shared to us, and also all participants to have a nice discussion during our session, and especially also for the organizer, the committee organizer of this seminar. Thank you very much. I also apologize if I have any mistake during my guidance during the session. I apologize and thank you very much. I hope we can meet again at another occasion. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Purwanto, for
Thank you,
joining us.
Purwanto. Thank you, everybody.
Thank you, everybody. I leave the session.
A building is inseparable with rehabilitation and maintenance. Rehabilitation and maintenance in civil engineering is as important as planning and designing. Rehabilitation is defined as the effort to regain building and infrastructure's function once defected or weakened, while maintenance is the effort to keep the building and infrastructure working as planned. The Department of Civil Engineering 11 Maret University, in collaboration with the Department of Civil Engineering Mataram University, proudly present to you the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering, Advanced Research and Technology for Rehabilitation and Maintenance in Civil Engineering.
Civil Engineering Department of 11 Maret University, in collaboration with other university partners, organized the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering, or ICRMCE. This conference is initially scheduled to hold offline in Mataram, Nusa Tenggara Barat, Indonesia. However, due to the escalating COVID-19 outbreak and the need for social distancing, we finally decided to shift the conference online. This conference is providing a forum for researchers, academicians, government agencies, consultants, and constructors to exchange experiences, technological advancement, and innovation regarding rehabilitation and maintenance of buildings and infrastructures. The previews for ICRMCE were successfully held in 2009, 2012, 2015, and the last one 2018, respectively. We hope that the ongoing conference will be a success and will serve as a positive step forward in the future. Stay healthy, and we look forward at the conference.
The
civil engineering study program, University of Mataram was born on November 8, 1991. The Department of Civil Engineering is supported by field of expertise of lecturers is divided into 5, 4 which are lab-based, plus the field of expertise in construction management. Until 2018, 2,243 civil engineering graduates have graduated. UMY's Civil Engineering Study Program is one of the first study programs held when Muhammadiyah University of Yogyakarta was established in 1981 and has received the accreditation of Grade A. Utama Karya is a construction company whose shares are 100% owned by the government of the Republic of Indonesia through the Ministry
Good afternoon, ladies and gentlemen.
Good afternoon.
Good afternoon.
Okay.
Good afternoon.
Thank you for coming to the second parallel session in the 5th International Conference on Rehabilitation and Maintenance in Civil Engineering in Parallel Section Class D. In this session, we will have 5 presenters. There are Dr. Rintis Handiani, Dr. Ing Suroso, Mr. Puji Harsanto, PhD, Mr. Wahyu Widianto, MT, and Ms. Humaira Saidah, MT. Let me introduce myself. My name is Retna Utami Agung Wiono. I'm serving as moderator in this class. And it is an honor for me to be moderator for distinguished lecturers, researchers. Hopefully, we will have a good collaboration in research next time. Okay, can we start the session? Okay, we will start the first presenter from Mr. Dr. Ing Suroso, because Dr. Rintis Handiani is not here yet.
Excuse me.
Yes.
My name is David. I'm the presenter for Dr. Rintis Handiani.
Ah, sorry. Okay. Thank you, Mr. David, for your presence.
Yes.
Okay. Mr. Adam, we will start from the paper ID 41. Yes. Please start.
Good morning, audience. My name is David from 11 Maret University, Indonesia. Thank you for the chance for me to present our research titled Validation of the RMM Rainfall Data on Slope Stability in Karanganyar, Indonesia, authorized by David Rajasi Maremare, Rintis Handiani, and Raden Haridananjaya. The National Disaster Management Agency, BNPB of the Republic of Indonesia, noted that in 2018, 151 landslides occurred in Central Java Province. Landslides can be caused by rainfall. Water falling down slope will become a burden to the soil, affecting its stability. The needs for rainfall data is essential in this case. The limited availability of rainfall gauges is a significant problem in Indonesia. Therefore, other data sources are needed to be processed in a particular case study. And one of the data sources is the Tropical Rainfall Measuring Mission, or TRMM data. TRMM is a joint project between NASA, America, and the Japan Aerospace Exploration Agency. But however, satellite data is considered fewer representative of the actual condition in the field. Therefore, validation of rain data needs to be done. The point of view carried out in the study is to validate the TRMM data to be used for safety factor analysis. So this is the study of literature. Research conducted by Shaifullah 2014 shows that GS map and RT has a better correlation value to data on rainfall at breeding station compared to data from 3B42RT. Test data homogeneity test was carried out to ensure that the data used were classified as homogeneous. And from superior, the variation of rainfall between stations is linear and any post is considered to represent the nearest area. ICRMCE method is considered possible to analyze the infiltration because this method also considers soil condition in determining the curve number. The intended research location is in Karanganyar. The taken soil data consists of 4 points locations spread over 3 districts, Pdsi, Karangpandan, and Tawangmangu. And secondary data goes through a data similarity process first to determine its homogeneity. Rainfall data TRMM and rainfall gauges experience homogeneity test with the Topsys method. Regional rainfall analysis use the Thyssen polygen method with a QGIS. Infiltration and saturated soil depth value for safety factor using analysis of ICRMCE method. The validation test validates rainfall data and use that valid data to analyze the safety factor. And this is the result. Analysis homogeneity for the rainfall data analysis shows that the data for rainfall gauge and TRMM are homogeneous. The next analysis is to process the maximum consecutive 2 days rainfall data based on the annual maximum 2 days rainfall data, and the recapitulation of the data is shown in the table. And we can see there are gaps between these two data. Validation analysis use maximum monthly data from 2014 until 2020. The daily rainfall data had a value that tends to vary between satellite and actual data. Analysis of 2 days rainfall data shows that the correlation coefficient is 0.22 and error value is 46.47 mm per day. And the analysis of total monthly rainfall data shows better value than the 2 days rainfall data. The correlation coefficient and error values are 0.76 and 251.63 mm per month, or equal to 20.97 mm per day. And by eliminating data that is far apart from other data, data is obtained with a tendency to approach the linear line formed. The equation we got is shown. And with the equation above, the calibration is carried out on each annual maximum rainfall data so that the maximum annual 2 days rainfall data is obtained as follows. So we can see that the data is more reliable than before. Slope stability analysis using the new developed web-based application called ONS-Lite, and these are the result. The safety factor maps from 2014 to 2020. The results show that the difference in the value of rain that occurs each year does not give much difference to slope stability. However, the greater the rain that occurs each year and occurs in long period, the greater the potential for landslide to occur. TRMM data can be used to overcome the problem of limited sources of rain data. If the study area does not have much reliable rain data, TRMM data can be used. Validation based on the total monthly rainfall data has a high enough correlation coefficient and a minimal error than validation based on 2 days rainfall data. The other suggests validating with more comprehensive rainfall data and various methods for its utilization. It is expected that more comprehensive rainfall data will provide more reliable accuracy and validation. The use of various methods to validate the DRMM rain data is expected to provide a new approach to lead the most reliable result in the future. And that's all the presentation. Thanks.
Okay, thank you, Mr. David, for the presentation. Now we will go to the Q&A session. I welcome questions from all participants in this room, please.
I want to ask questions.
Yes, please, Mr. Farhan.
Yes. Would you explain how do you get the SF maps? Thank you.
Okay, thank you for the question. Please, Mr. David, to answer the question.
Okay, thank you, Mr. and Mr. Farhan. I will answer the question from Mr. Farhan. From the SF maps is cut with some apps. It is called UNS Lite apps. UNS Lite apps is a website-based apps to analyze the safety factor, and the UNS Lite use infinite slope method, and the thing we have to do is just need to input the slope data, the phi and infiltration data, and the equation data of the data, and the SF map is analyzed automatically with the website or the apps when it's like. But unfortunately, I'm not the developer of the apps of the program, and so that's what I could tell you about how to get the safety factor maps from the OneS Lite application.
Okay, so the safety factor map was taken from.
Good afternoon. Thank you.
Yes. Yes, please.
Excuse me, Miss Ratma.
Yes.
I wanna ask a question.
Okay, please.
That's a great presentation, Mr. David. And I will ask a question: how you find the equation to calibrate the rain data?
Thank you. About the calibration of rainfall data. Please, Mr. David.
Okay, thank you, Mr. Nayu. If you mean that the equation of the calibration, the equation is cut with the calibration method itself, and we know the rain data is discrete data, and if we put the data to the scatter plot, we will get the line, and we will see that there are separated points with the line, and if with removing that points, we will get the few points that approach to the line, and that line we will use it to create the equation. So the equation of the line to calibrate the rain data is get with the points.
Okay, do you have further question, Ms. Ratmayu?
I think that's all, Miss.
Okay.
Can I have question?
Please, Dr. Suroso.
Yes, first of all, I think it's great presentation for David Rajasimaria about validation of stream rainfall data. Yeah, but I have a question. Number one, how do you compare, or how do you validate stream rainfall data based on observation? Because as far as I know, stream rainfall data is a grid, right? It's a grid. It's a point grid, but for observe rainfall data is a point. So do you consider area rainfall or not? This is the first question. And the second one, as I understood correctly that you compare scatter plot, scatter plot between trim and observed rainfall on a monthly, daily scale, monthly and daily scale, and you show me that you show us that monthly look better scatter plot compared to daily or 2 days rainfall. I forgot. So do you any reason for that? So you mentioned that maybe monthly rainfall is better than 2 days rainfall. Yeah, and do you just create regression linear? How do you convince me that your model is reliable? You said in the presentation that this model, regression model, is reliable. How do you conclude that your model is reliable? Is there any parameter to say that your model is good or not, or just using determination coefficient or correlation coefficient or other? Thank you. I think that's all.
Thank you very much, Dr. Soroso, for the question. Please, Mr. David.
Thank you, Mr. Soroso, for the question. To validate the data, which is the RMM and rain gauges, of course we also compare with the area. If as we know, TRMM data, which is I used, is from JAXA TRMM JAXA data, which each point have a range 10 kilometers times 10 kilometers, which is 100 kilometers square. And with that points, I used that, compare it to the maps I've shown you before at the presentation. So that's right. We also validated in the same area. And for the second question, to determine the data, from the data I found that the monthly data has a smaller error, which is I used root mean square error method and with an coefficient correlation method.
Okay, thank you.
Okay, thank you very much, Mr. David, Mr. Soroso, for the question and answers. I apologize that because the time is up for this paper. So, Mr. David, I would like to ask you to answer the question from Mr. Abdurrahman in the chat room. Could you? Because the time is up, you can just answer it in the chat.
Okay, thank you.
Okay. Okay, thank you very much, Mr. David and all participants for the first presentation and fruitful discussion. Let's go to the second paper entitled Hourly Rainfall Simulation Based on Daily Data that will be presented by Dr. Soroso. Soroso, time is yours.
Well, good afternoon. Thank you very much, everyone, for having me to this talk. My name is Soroso. I'm presenting our research paper entitled Hourly Rainfall Simulation Using Daily Data. This is a part of our research collaboration project with Fatimatus Suliha Marus and Dr. Eng Purwanto Bakti Santoso. This is the overview of what I'm going to present. First, I will give you some backgrounds and motivations why this topic is interesting and why I choose to do this study. Then, I will talk about the purpose of this study. After that, material and method of this research will be presented, including study location, data, its type, spatial and temporal coverage, and its quality, as well as the method. Afterwards, I will go over some empirical investigation research. At the end of my talk, I will conclude the finding of this research.
Precipitation is one of the main and important inputs of hydrological system analysis, which are implemented in many areas of water resource project, including flood mitigation strategies. Unfortunately, precipitation data are frequently inadequate in observation data set in terms of length of data, spatial coverage, and also completeness. This is because of the small number of spatial observation on the error of instruments. Insufficient precipitation data regarding time series length and spatial coverage can lead to a serious problem in hydrological analysis, resulting in either underestimation or overestimation of hydrological values. To overcome the lack of high quality of precipitation observation data, rainfall models are required to fill in missing values as well as to extend the length of data at an observed location. The goal of the current research is to derive hourly rainfall data based on daily data, while daily rainfall data have a better quantity and quality rather than hourly data. Let's move to the data and study location. The data in the study were obtained from the Meteorology, Climatology and Geophysical Agency, or BMKG. Rainfall data used here is on hourly and daily scales. The study location was taken from the rain gauge station with having relatively complete data from all stations in Java Island. Now we are going to talk about the method of research. The following step in preparing the data are the all rainfall stations that have a relatively long measurement period, complete and continuous, are identified and selected for further analysis. Then, for each hourly rainfall station that has been selected, the cumulative rainfall amount on a daily scale is carried out. Two data sets of rainfall are collected at the same time. There are two types of modeling approach are taken here, namely the approach that the rainfall data series for both zero and non-zero rainfall was calculated, and another approach that only non-zero rainfall data series were carried out in the modeling stage. After obtaining the hourly rainfall simulation modeling using daily rainfall data, it is necessary to evaluate to obtain the performance of the model. There are several measuring tools to find out how well the modeling developed, consists of mean absolute error, root mean square error, Spearman, or Pearson correlation. Okay, now I would like to talk about some empirical findings of this research. Completeness of rainfall data is an important aspect in knowing the quality of hourly and daily rainfall data. Rainfall data on hourly and daily time scale used in the study were taken from 1981 to 2019. However, the available rainfall data, especially on the hourly time scale, is inadequate, so that a lot of rainfall data is not recorded or not available in A. From the 25 stations, the percentage of missing values in A, that is less than 31% of of total data, Citeko, Stasiun Citeko, and Stasiun Dermaga. For Citeko, it has around 24% of data missing, and for Dermaga, it has around 30% of data missing. Based on the investigation from the rain gauge station that have relatively good quality of hourly rainfall data, namely Station Citeko and Dermaga, and using two different seasons, the wet and dry season, we have found the most interesting finding, that is a daily cycle. What does mean daily cycle? There is a general diurnal pattern that rainfall events mainly occur in the specific time for the majority of wet days. Many rainfall events are concentrated in the afternoon or at night. This is because during morning to noon, water has been evaporated and it forms clouds. Then, in the afternoon or evening, the cloud begin to condense and it rains. A rainfall simulation model is made
been based on the concept of daily cycle. By considering the mean values of hourly rainfall scaling to daily amounts, hourly rainfall value can be easily generated. Okay, now I would like to talk about how to evaluate the model. First evaluation is how similarity of the mean values of simulated hourly rainfall to the mean amount of observed hourly rainfall. You can see here in the figure that the mean values of hourly rainfall for both observation and simulation has a quite small differences. The daily cycle of hourly rainfall from observation can be mimicked by the model quite well for both rain gauge station and both season. The next evaluation of the model is how small error or bias of the simulated rainfall values compared to the observed rainfall can be obtained. Here we use mean absolute error and root mean square error for the second evaluation of the model. The two prediction models are said to be best if the values are close to zero. From the figures shown that the error also have pattern of daily cycle following the early rainfall intensities, indicating that heavy rainfall events tend to have bigger bias. However, the average error value of both mean absolute error and root mean square error are relatively small for both location and both season. The last model evaluation is determined by correlation coefficient between simulated and observed rainfall. Here, the two types of correlation value, Pearson and Spearman correlation coefficient, are selected for this research. It can be seen from the figure that the pattern of the Pearson and Spearman correlation coefficient value for both data set, simulation and observation, are similar for both rain gauge station as well as for both seasons. However, the correlation coefficient for both of them is quite small because it cannot preserve temporal series dependencies properly than normally used for forecasting purposes. Nevertheless, for design purpose, the model can be used because it can maintain the characteristic of data sets, such as mean values. In conclusion, based on quality of hourly and daily rainfall data, it's shown that the quality of rainfall data at 25 rain gauge stations in Java Island is generally not good, so that only 2 rain gauge stations are selected for this research, namely Citego and Dermaga. There is an interesting result on how characteristic of hourly rainfall occurring for every wet days. The hourly rainfall has a daily cycle pattern, that is, rainfall events are concentrated in the afternoon or at night. There is a similarity pattern between simulated and observed rainfall value for both wet and dry season, including mean values, error or bias, and correlation coefficient. This hourly rainfall simulation modeling using daily rainfall data can be used for design, especially in the field of hydraulic structure construction. However, for forecasting purpose, further modeling is required. Well, good afternoon. Thank you.
Okay, thank you very much for the interesting presentation, Dr. Soroso. Now we will go to the Q&A session. I welcome questions from all participants in this room. Okay, while waiting, I would like to ask one question, Dr. Soroso. Regarding the daily cycle that you explained in the presentation, did you observe the similar pattern of daily cycle of rainfall in other places? Or maybe it happened only in one area, or how do you know about that?
Thank you very much for your questions. So as I shown on my presentation that unfortunately I only used two location, Citego and Dermaga, because we only have 2 rain gauge stations with good quality of data, because we need to have long data sets from 1980 to 2019, so more than 20 years or 30 years. So if you look at the slides, and the quality of data, rainfall in Indonesia in general, or in Java specifically, is very bad. Yeah, if compared with, to be honest, compared to other countries. For example, I have data in Singapore. So Singapore is very complete, even in minute or early rainfall. They have a continuous observation. Yeah, so in this case, I didn't analyze other area because no data available. Actually, no data available. But maybe because of Java has a typical tropical regions, maybe we have a similar pattern. So maybe you can memorize. You can maybe memorize that rainfall normally occur in the afternoon, right? Afternoon, evening. Normally, not
Yes,
not
yes.
always, but in general.
Yes,
Maybe.
yes.
So this is
That's
like a breakthrough that we can derive all the rainfall based on the daily or diurnal cycle. If we compare to other country, for example, Europe or German, the rainfall is totally random. Rainfall can occur in the night, in the morning. There is nothing pattern or daily or daily cycle or diurnal. Yeah, that's all.
okay. Thank you very much. Maybe one other question from Mr. Abdurrahman.
Yes.
I just got that you compared rainfalls data of two sites. I still have not understood what the variables of your models are. Could you
Yes.
mention again?
I didn't compare to sites. Yeah, this is just sample. I use to rain-gauge station as a sample. Yes, I taken to station just for sample. So actually the goal is just how to derive daily rainfall into early rainfall. So I just investigate the character of daily rainfall and early rainfall, and then I go from that to build model. Actually, this is still preliminary research. Then we will develop a sophisticated model. Yeah. That's
Okay,
what I
thank
think.
you very much.
Interpolation. No, not interpolation. We just derive. So imagine that you have a 100 millimeter, for example, 100 millimeter a day, or maybe 50 millimeter per day. How to derive, how to distribute it? Yeah, how to distribute it into 24 hours. And this is because we totally don't have any earth observation. Yeah, this is like empirical approaches. I think that's all. Thank you.
Okay, thank you very much, Dr. Suroso, for extensive explanation about this paper. Let's give applause to Dr. Suroso and also for Mr. David before. And let's go to the next presenter. Paper number 107, entitled Small Debris Flow Simulation Using Morpho 2DH by Mr. Puji Harsanto, PhD. The time is yours.
Good afternoon, everyone. I'm Puji Harsanto from Universitas Muhammadiyah Yogyakarta. Today, I will present our research, which the title is Small Debris Flow Simulation Using Morpho 2D. Today outline is research background, study area, research method, result and discussion, and conclusion. Background. This is the map of Yogyakarta. Yogyakarta has a very active volcano located around here. This eruption occurred, the big eruption occurred on 2010, and sometime or many times a small eruption occurred. So when the eruption occurs, the sediment material from the Mount Merapi will deposit around here and will flow down to the river
which originate at the Mount Merapi. So some of the river which originate at the Mount Merapi has a potential hazard, namely flood with high sediment concentration. In bahasa we call banjir lahar dingin. The flow with high sediment concentration give a significant impact on the river morphology process and of course give impact on the riverbank protection. Due to the river flow through the city and have many bank protection, so the river morphology should be pay attention more in Yogyakarta. This is the illustrate for the Mount Merapi eruption. Then the sediment material deposit at the upstream area and will flow down, and the river has a flow with high concentration. So the problem is about the sediment transport, erosion depth, riverbank protection. The purpose of this study to analyze riverbed erosion due to the concentration of bedrock transport and the benefit of the simulation is related to the morphology process, related to the evaluate of the river construction. So the study area is located around here. This is the city of Yogyakarta, and the length of the segment rivers is around 1 kilometer. And we use Morpho 2D. This is the software integrated on the IRI company, and the software is developed by Hiroshi Takebayashi from Kyoto University. The software is two-dimensional flow analysis which contributes to the sediment concentration. The small debris flow simulated by ratio of sediment concentration to the equilibrium condition. When the ratio is 1, means that the bed load transport in normal condition, but if the ratio is more than 1, it means that the sediment transport with high concentration occur or small debris flow occur. This is the grain size from the river, and also this is the data, the discharge we got from the BBWS Serayu Opak Progo, Balai Besar Wilayah Sungai Serayu Opak Progo. And also the cross section we got from the Balai Besar Wilayah Sungai Serayu Opak Progo. And the step for the modeling is load the bed elevation and generate the grade calculation, setting the parameter of the calculation and setting the calculation condition. We set the sediment ratio concentration in this step and run, then we got the result. So some area of the river, the bed erosion occur more when running with the small debris flow condition. This condition can be explained as follows. When the bed load transport occur, some area will have deposition in a large volume. Because of the deposition, the capacity of the cross-section will decrease. And this condition will force the increasing of flow velocity at the another side, or at the around the deposition, or at the opposite side of the deposition. The increasing of flow velocity will produce the increasing of bed shear stress. Then the increasing of bed shear stress will produce more erosion and more degradation. As we can see in the photo, this is the photo from the segment river, one of the segment river. We can see this is the crack of the riverbank protection. So when the degradation occur, more will give impact on the stability of the construction of the riverbank protection. The riverbed degradation occur around here will impact on the foundation of the riverbank protection. And the riverbank protection will failure. As we can see at the photo, this is the line of the construction. It's not strike again. It means that the foundation of the construction is not unstable again, or it's not in the normal condition. So for the conclusion, the model can simulate the flow and bed degradation and aggradation, which is similar to the real condition. In general, the maximum flow velocity occurs when the sediment concentration less than 2 times of equilibrium condition. When the sediment rate more than 2 times of equilibrium condition, the degradation will decrease rapidly. So the model can be used or should be performed when we designing of the bank protection to predict the situation or the stability of the river bank protection construction. Thank you very much.
Okay, thank you very much for Dr. Puji Harsanto for the very interesting presentation. Now I welcome questions from all participants about this topic. The first question will be from me. Dr. Puji Harsanto, I know about this IRIC model several years ago, but I just heard it. And what do you think about this model compared to, for example, HECRAS that so many people use that model before? And you have any comments?
Okay, thank you very much for the question. Yes, this model is about two-dimensional flow, and if we compare to another software, for example, now you know that HECRAS also they have a two-dimensional, and also another SMS. But in the HECRAS and also another software, all of the sediment transport flow all on in the normal condition or in the equilibrium condition. So we cannot setting if the flow with the high concentration is we cannot setting on that software. So in this software in Morpho2D, we can set the condition of sediment transport flow with a high concentration. But the difficulties in this software is as long as I know that the stability of the calculation is rather difficult, because when we run with the long time step is sometimes just stop in the middle or not finished yet. And for HECRAS, I think the HECRAS is the stability is very good, and also now the sediment transport calculation in HECRAS also in the last version, in version 5, I think also okay. But yes, if we want to predict for the breeze flow, we cannot use it for the HECRAS or also the SMS. Maybe we cannot simulate the breeze flow.
I understand. So the small debris flow is the yes, the good side of this Morpho2D. I'm sorry, there is another question in chat room from Dr. Abdurrahman. Could you please give a bit technical example of how to incorporate the results and the insights from your model into the design of a riverbank? Please.
Yes, so in this model, we can calculate the bed degradation or bed morphology, two-dimensional, and we can predict the elevation of the riverbed so we can adjust the depth of the foundation. For example, in that in my presentation, actually not only in one place, we survey some place that riverbank protection, some fail due to the foundation is not in the stable again. So it means that the foundation how to say, the bed degradation is more than the elevation of the foundation. So it means that we have to predict how deep the potential of a riverbed if the degradation occur. So I think that is.
Okay, thank you very much, Dr.
Thank you very much.
Santo, for the answers. I think it makes the results and the presentation becomes more clear for all of us. Okay, let's have a thank you very much for Dr. Puji Harsanto. Yes, okay, thank you, and we will go to the next paper, paper ID 108, entitled Tsunami Hazard in Cilacap City Due to the Megathrust of West Central Java Segment, by Dr. Wahyu Widianto. The time is yours.
Assalamualaikum. Hello everyone. We are pleased to be able to join the International Conference on Rehabilitation and Maintenance in Civil Engineering. In a pandemic situation, this conference is still carried out with enthusiasm. Good luck. My name is Wahyu. I am the first author and Mrs. Sanitya is co-author. We work in the Department of Civil Engineering at Universitas Jenderal Sudirman, but we are currently pursuing PhD at the Department of Hydraulic and Ocean Engineering, National Cheng Kung University, Taiwan. The title of our article is Tsunami Hazard in Cilacap City due to the megathrust of West Central Java Segment. We would like to present our paper with contents including introduction, method, and result. In introduction part, we would present study area, source of earthquake and tsunami, and in the method section we will present tsunami generation, tsunami propagation, and multi-grade coupled tsunami model. While in the result section, we will discuss 2D view of generation and propagation, water surface elevation, conclusion, and recommendation. This is the study area where we conduct a tsunami simulation to determine its impact on this area. This is an image taken from Google Earth, which shows the city of Cilacap and its surrounding. In this area, we will evaluate 7 important point, 1, 2, 3, 4, 5, 6, 7. And the point are Lapas Permisan Nusa Kambangan, second Pelabuhan PT Pelindo TNI AL, third Dermaga Kilang Minyak PT Pertamina, fourth Benteng Pendem, fifth Pelabuhan Perikanan Samudra Cilacap, sixth PLTU Karangkandri, seven PLTU Adipala. The 2 columns following here are the coordinates or longitude and latitude of each location. In addition to the location studied, we also need to review the source of tsunami. Since in the study we are limited to earthquake-generated tsunami, the tsunami source area is the same as the earthquake source area. As we know that Indonesia has a ring of fire, which is located under the sea, extending from northern tip of Sumatra to Nusa Tenggara, and even approaching Maluku and Papua. This map is sourced from the Pusat Gempa Nasional Pusgen, describing the sources of earthquakes. For Cilacap City, the closest earthquake source is the megathrust of West Central Java. This segment is located in the subduction zone. The method we use is numerical simulation. Tsunami wave generation is based on Okada's theory, which requires input, epicenter, focal depth, fault length, width, strike angle, dip angle, slip angle, rig angle, and slip. And as for tsunami wave propagation, the shallow water equation uses a spherical coordinate system and leapfrog numerical scheme. Both processes are carried out using the ComCode model. This is an open source software. The result of numerical simulation can be presented in a horizontal 2D view like this. Figure 4 is the beginning of the simulation, a change in the sea level due to the deformation of sea floor by earthquake magnitude 8.7. The red color stands for the rise in the water level and the blue color for the fall of the water level from MSL, mean sea level. So the red is higher level, the blue is low level. The figure 5 is for tsunami propagation process after 20 minutes from the earthquake. The right image shows the tsunami almost reaching the coastal area when propagate around 20 minutes. We can see that the wave height approaching the coast is reddish in color, indicating a significant tsunami height. If the snapshot is taken at a longer running time, in this case we take 2200 seconds or 36 minutes, we will find that the tsunami waves have arrived in the study area. Figure 6 reached the city of Cilacap. The tsunami reached the city of Cilacap after traveling from the source of the earthquake in the Indian Ocean. Figure 7, the simulation result taken from a rise in the water level due to the tsunami at several observed points in the Cilacap city. The tsunami height at the site under review is shown in this graph. The highest is seen at the location of PLTU Adipala, which is depicted by this blue curve. Several conclusions can be drawn. Cilacap coast has significant potential for a tsunami. High tsunami can occur at the PLTU Karangkandri and the PLTU Adipala with 6.7 and 10.7 high, respectively. In addition, we also recommend several future work, including it is necessary to consider the source of earthquake and tsunami for other nearby megatrust segment, such as Enggano segment in the western part and East Java segment in the eastern part, and also considering probability tsunami hazard assessment. Thank you.
Thank you very much, Mr. Wahyu, for the very interesting presentation about tsunami modeling using ComCode. And now I welcome questions from all participants in this room.
I have question, moderator.
Yes, please.
Okay, I'm Puji. I have two questions to Pak Wahyu. The first question is, how are you? Because a long time I didn't meet you. And the second question is, can you explain about the how far the impact if for the megatrans tsunami, the impact from the beach to the land area? Can you explain the impact, for example, 1 kilometer or something? Okay, thank you.
Okay, please, Mr. Wahyu.
Okay, thank you for the two questions from Dr. Puji Arsanto. The easy answer is the first question. I'm fine. I'm fine, but I'm still in Taiwan now. But next week I will go back to Indonesia. Especially I will sleep in my parents-in-law in Yogyakarta so we can meet each other, I think. And the second question is the general and important question, usually for mitigation measure. After we have the approximation of tsunami height or tsunami amplitude, then how far the impact for the coastline and the further the land area. So it depends on the magnitude of earthquake and the size of tsunami. So in my study or in my presentation today, I only show one magnitude 8.7. This is because the worst case scenario in the Cilacap city due to the megatrust of West Central Java. So the impact usually is different between one point to another point. For example, between as you can see in my result that I compare Benteng Pendem with PLTU. This is very significant difference. Benteng Pendem only attacked by tsunami around 2 meters, but the PLTU Adipala can reach 10.7. So it is many factor. Usually bathymetric is the play important role to the tsunami height in the coastline, not coastal area, coastline or shoreline. The shape of bathymetry, the steepness of bathymetry, and the direction of the coastline to the earthquake source. For example, in Benteng Pendem, the tsunami hit only lower height because the tsunami has to become refraction process. So maybe this is the direction of the tsunami from the south, but the PLTU Adipala is directly straight from the south. This is also the influence to the head of tsunami, and the impact of the land is depend on the tsunami amplitude in the coastline. If the tsunami amplitude in coastline high, so the run up usually also high, and the inundation distance also far. For example, in Palu tsunami, when we have experience to make a field survey in Palu, we measure many different between one point to another because of the topography and the tsunami head in the coastline. For example, in Palu, the farthest long inundation distance is around 500 meters, but some place only 50 meter, 120 meter, and so on. So this is because of the slope and also the tsunami incoming in the first time. Okay, I think.
Okay, thank you very much.
Yeah,
Thank you very much, Dr. Puji and Mr. Wahyu, for the answers. It's actually very interesting, but I apologize that the time is up. So maybe later I can send you email to ask about the study. Okay, let's give applause to Mr. Wahyu Widianto for his presentation. Okay, now we will go to the last presentation. It will be given by Mrs. Humaira Saida, paper ID number 113, entitled Comparison of Suitable Draft Indices for over West Nusa Tenggara. The time is yours.
Good noon, ladies and gentlemen. Today I will present my research with the title of Comparison of Suitable Drought Indices for Over West Nusa Tenggara. My name is Humaira Saida. Here is my team, Mr. Haris Listiono and Mr. Idewa Pdsi Negara. This is the outline of my research presentation. West Nusa Tenggara has often experienced drought. The drought occurred almost every year and causing crop failure and even causing famine in 1966. So it is very essential to understand the characteristic of drought in this area and find the suitable drought indices assessment method in early anticipation of drought hazard. There are many methods applied in examining drought indices worldwide, and there is no guide how to choose the suitable one for any particular condition. The aim of this study is to determine the best approach for a drought assessment by comparing two drought index model, SPI, Standardized Precipitation Index, and Pdsi, Palmer Drought Severity Index, and test their proximity to drought data in West Nusa Tenggara. This is the research methodology. First, we have to collect some data like rainfall data, air temperature, soil type, soil structure, land cover, and drought data. Then we have to calculate drought index using SPI and Pdsi models. Then we compare drought index of SPI and Pdsi with experienced drought data. And the last one is scoring and evaluating the suitableness of those models. This is the study area and the data availability. The rainfall data available from 1997 to 2018, so the air temperature data. And the drought data, in average in West Nusa Tenggara, only been recorded from 2012 till present, but in this study, it will depend on the region. It's vary from one to other region. This is one of the data we collected from West Nusa Tenggara Regional Board for Disaster Management. This is the drought experience data for West Lombok District. Then we presented in numerical. The 0 point means no drought and -1 means dry period. After we collect the data and presented in numerical table, we continue with calculating SPI drought index, and this is the result of calculating SPI index for West Lombok from 1997 to 2018. Although we calculate SPI from 1997 to 2018, but we only use for latest year to be compared with drought experience data, since the drought experience data only been recorded from 2014 for West Lombok District. This is the result of Pdsi, and we also will compare the four latest year to be compared to experienced drought data. And this is the SPI value for West Lombok District. The red letter means the dry period. Then we will change this table with the new score. The value that less than -1 indicated there is a drought period. So we will give score -1. In order to make the same scale to drought data from BPPD, we change this table into the new one. The index that less than -1 means there is a dry period. So we will give score -1. And the index that more than -1, we will give 0. It means there is no drought. This is the Pdsi value for West Lombok District, and the same rule will be applied to Pdsi table. The next analysis is the suitability analysis. The suitability of the model was measured by the number of match scores between SPI and Pdsi scores to BPPT drought data score. For the example is in July 2015. SPI resulted no drought condition, but Pdsi resulted drought condition. And BPPT recorded drought at the time. So SPI do not match with BPPT, so we give 0.0. And because Pdsi and BPPT is matched, so we give 0.1. The next step is sum up the total of matching score. Then we sum up the total of matches value from SPI to BPPT and Pdsi to BPPT, and we got 32 for the matches of SPI and 37 the matches of Pdsi to BPPT for West Lombok district. This is the total of the result matches of the two models from all of district in West Nusa Tenggara. The blue one is percentage of match SPI and the red one is the percentage of match Pdsi. From this graph, we know that Pdsi has a higher number of matches to BPPT, more than SPI. It shows that Pdsi give a better performance than SPI to detect the drought condition in West Nusa Tenggara. So due the correlation coefficient, Pdsi have a higher number of coefficient correlation, more than SPI. Conclusion. The Pdsi method provides a better estimation of the drought period in the study area than the SPI method. The result calculation of suitability shows that the Pdsi and SPI method have an average suitability percentage of 75% and 58% and a mean correlation coefficient of 0.51 and 0.06 respectively. Besides requiring more data input, the Pdsi method has a higher level in difficulty than the SPI method in the calculation process, so that is in application, the SPI method is still interesting to apply. Thank you.
Okay, thank you very much, Mrs. Humaira Saida, for the very interesting presentation. Now we will go to the Q&A session. I again welcome all participants to raise questions. Please.
May I have one question, please?
Yes, please, Mr. Hidayat.
Thank you very much. And I'm interested in the correlation coefficient calculated in Central Lombok. The values are considerably lower than those at any other study areas. Maybe Bu Humaira has an explanation about this, why the correlation coefficient in Central Lombok are considerably lower than any other areas. Thank you.
Yes, please, Mrs. Humaira. You are still muted.
Okay. Okay, thank you, Mr. Samsul, for the question. Yes, from the result of the coefficient correlation of all district in West Nusa Tenggara, Central Lombok has the lowest correlation coefficient, but from the analysis, the Pdsi still showed the good performance actually, but maybe it caused by the time of the drought started. It's not accurate, but the accuracy is good in in estimates the length of the drought duration. Maybe it caused by the validity of the supporting data like rainfall data, air temperature, and other supporting data is very poor. Maybe, but it's only my opinion.
Okay.
Thank you very much.
Yes, Mr. Hidayat?
That's fine. Yep. Thank you.
Okay. Okay, thank you very much for the question. The second question from Dr. Gusvan Halik. Thank you, Mrs. Humaira, for your presentation. I'd like to ask why the Pdsi method provides a better estimation of drought disaster than SPI method. We know that the SPI method has been accepted as an international consensus for monitoring of meteorological drought disaster, and SPI has advantages on the time scale. Please.
Yeah, because of this, in this study, I compare the SPI and Pdsi to the experience data, the experience drought in Lombok. The experience drought means there is no access of people to water, like rainfall water, surface water, or so it means this is not only a meteorological drought, but the drought that I compare to is maybe hydrological or hydrological drought or social drought. I think that is the differences, yeah. Because SPI and Pdsi actually is a meteorological drought, but I compare it to the actual drought. That means that there is a combination from this drought.
Okay, thank you very much for the answer. The next question from Mr. Samsul Hidayat again. Why are the correlation coefficient values in Central Lombok considerably lower than those in any other study areas?
It's the same question actually. Yeah, it's the same question actually.
Ah, okay. The same question that already answered.
Thank you.
Okay. Thank you very much. Okay. Unfortunately, the organizing committee remind me that the time is up. So I think this is the end of our second session in this parallel session today. Here I would like to again thank all of the presenters, all participants for the nice and fruitful discussions, and also for all the committee, the secretary, and also the organizing committee for the nice arrangement. I close the today's session. Thank you very much. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Tsunami.
Thank you very much.
Thank you very much, everybody. Bapak Ibu.
Jangan lupa isi absennya.
Oh ya. Biar mendapat sertifikat, Bapak.
Makasih Bapak Ibu, saya pamit dulu.
Terima kasih Bapak Ibu. Thank you.
Sama Bu.
A building is inseparable with rehabilitation and maintenance. Rehabilitation and maintenance